later residue. Okay, so let's proceed with the acid-base equilibrium calculation technique. No? So last time we were able to answer a problem, no? So we were able to answer this problem, no, using the ice table, and then later on we did the algebra dito. Nag-ano tayo, quadratic equation. We actually got the x value equal to 0.029 ba yun? If naaalala ko pa siya correctly. So yun, nakuha natin x is equal to 0.029 if I'm not mistaken using quadratic equation. The problem with that is, suppose quiz nyo ngayon, tapos 20 items na ganun. O kaya midterms nyo ngayon, tapos sandamukal na items na equilibrium. Will you be able to finish your test agad? Hindi, no? Kasi doing the ice table will take you around 1 minute, no? And then doing the algebra, that will take you a variable amount of time, no? Kapag kaya ng calcu nyo, mga 2 minutes, tapos na kayo sa problem. Pero pag di kaya ng calcu nyo, you have to do it manually. It will take you around 5 minutes to accomplish the item. So, today, I'm sharing you the technique that we use, no, to simplify the calculation. We call this the small x approximation. And this can be applied if your reaction is strongly product. That means K is greater than 10,000. O kaya, this can also be applied, excuse me, when your K is times 10 raised to negative 4, no, or less. That means it is strongly reactant. So ano ba idea natin dyan? Kapag ang K natin is 10 raised to 4, that means the reaction will proceed towards the product side. So most of the equilibrium species ay yung products. Kapag ano naman, K is equals to 10 raised to negative 4 or lower than that, that means most of the equilibrium species ay reactant. No? So, yan. So, ayun yung unang ite-check mo if you can use this technique. Tignan mo muna if ang exponent ng inyong scientific notation ay positive 4 or less than 4 below. Okay. Positive 4 above or less than 4 pababa. No? So, tignan nyo lang no, kung ano yung maging exponent niya. Pagpasok na siya doon, eto, sumunod yung gagawin. So, susunod yung gagawin, pag qualified siya sa first criteria natin, punta ka dito. Gagawin nyo dito, you divide the concentration of your reactant by the constant. Okay. I-divide mo sila and check if that is greater than or equal to 1,000. Because if the ratio of the concentration and the K is greater than or equal to 1,000, that means you can use the small x approximation. So we call this the small x approximation. Ano ginagawa ng small x approximation? Small x approximation actually helps us to minimize the use of quadratic equation. So if ang inyong problem capable siya dito sa, or I mean compatible siya dito sa technique na to, hindi na tayo quadratic equation. Okay? So mas mapapadali buhay natin pag ganun. Okay? So, pakita ko sa inyo isang example how to use the small x approximation. Kasi yung mga words na yan, eme-eme lang yan. No? As is pa rin yan. Pero sabi dito, if yung problem hindi siya hindi siya pasok sa criteria natin for the small x approximation, then you have no choice but to use quadratic equation. So, bali, yun yung una nyong gagawin. When you see an equilibrium problem, you check if kaya yung small x approximation. So, given ang previous item na sinagutan natin last time, sagutan natin siya uli. But this time, let us see if we can use the small x approximation. Sabi dyan, calculate the equilibrium hydronium ion concentration from 1.2 molar nitrous acid given the reaction and the Ka. Okay, so yan. So, anong unang mong gagawin? Bago ka mag-continue with the problem, you check first if you can use the small x approximation. How? Tignan mo lang, ano yung Ka mo? 10 raised to negative 4. So mukhang pasok siya. So sumunod mong gagawin is, you divide the concentration of your reactant by the Ka. Yung reactant mo dito yung nitrous acid. So i-divide mo yung concentration ng reactant over the K. Or in our case, this is the concentration of acid over the Ka. Cha over Ka, no? Tapos mamaya magiging tsaka na yan, no? Share ko na yung mamaya. Mamaya yan. Okay, so sa ngayon, Cha over Ka muna. Concentration of acid divided by the Ka. Tignan natin if ang kanyang ratio ay greater than 1,000. So we have 1.2 for the numerator. Ito yon. And for the Ka, we have 7.1 times 10 raised to negative 4. So, ano yung reason ni Cha pati ni Ka? No? Siyempre, di ko yan kaya i-mental. So, pindutin sa calcu. That's 1690. Okay? So, that is greater than 1,000. So, ano implication nun? If the ratio of the concentration of reactant and the K is greater than 1,000, you can use small x approximation. So, pwede natin gamitin yung small x approximation dito. Paano yon? Paano yung small x approximation? Ganito lang. You start your usual routine. Gawin mo pa rin yung usual routine mo in answering equilibrium problem. So, kumpletuhin mo yung ice table. Usual routine muna, no? So, kumpletuhin mo yan. 1.2 for the acid, 0 for the others. So, since 0 yung others, sila yung positive, negative for the acid. Diba? Tapos agad. So, ano yung susunod na ginagawa natin? After ice table, ilagay siya sa K. Okay, so Ka, that is the products, X, and another X, over reactants. So, ayan, routine calculation. So, kinumpleto natin yung ice table, pilinagin natin sila sa Ka expression. Dito na ngayon papasok yung small x approximation. Saan? Ganito. Sa equation na to, sino yung dahilan bakit nagwa-quadratic equation tayo? Okay, ito yung itsura ng quadratic equation. Sino yung may kasalanan bakit tayo naghihirap sa quadratic equation? Yung x sa denominator. Yan yung may kasalanan. Bakit? Kasi ito x squared to eh. Ito yon. Yung x term that came from our denominator. So, siya yung dahilan bakit nagka-quadratic equation tayo. Kung pwede lang mawala siya, we can solve for the value of x by getting the square root, di ba? X squared to, constant yan. So, kunin mo na lang yung square root, no? Kaso hindi eh. In our case, may bx term tayo. Kaya nagka-quadratic equation tayo. Dito papasok yung small x approximation. Ano gagawin natin? We will assume that the x in the denominator is negligible. Ibig sabihin, pwede burahin. So, yun yung gagawin natin. Since pasok siya sa ating criteria for the small x approximation, then we are safe to say that the x on the denominator is negligible. Ibig sabihin, pwede na natin siya burahin. Okay? And as we remove the x in the denominator, our equation now will be simplified. Okay? And you can solve for the value of x by just obtaining the square roots. No? Kukunin mo na lang yung square root. No? No more quadratic equation. Okay? So, yan. Again, bago ako mag-proceed sa pag-solve ng x, bakit ko binura yung x sa baba? Kasi pasok ako sa criteria for the small x approximation. That is yung concentration divided by K If that's greater than 1,000, pwede mo to gamitin. Okay? So ano gagawin mo pag pwede gamitin yung small x approximation? Yung minus x dito sa baba, di ba originally ano yan? 1.2 minus x. Yung minus x mo dun sa baba, pwede mo na siya burahin. Okay? Kasi we assume that the x is small. Kaya small x. We assume that that value is negligible or small. Therefore, we can just assume na hindi siya nagmamatter. So we can simplify our equation as this. Okay? And then you solve for x, no? So you have x squared equals 1.2 Ka. You get your x equals square root of 1.2 Ka, or that's equal to 0.029. The same answer we get, no, when we did the quadratic equation last time. O, diba? So, ang bilis, diba? So, kapag hindi ako nagsalita, tapos yan, less than 1 minute, no? Pero, yan, explain ko pa. So, yun yung importance ng small x approximation. You can easily get the x value when you assume that the x on the denominator is small. Okay. So you check muna if you divide the concentration by the Ka, if that's greater than 1,000, pwede mo siya burahin. Pag binura mo yon, the solving for x will be very smooth na, very easy. Okay. You will just get the square root of the concentration of acid times the Ka. Kaya ang tawag namin dito ay square root of tsaka. Okay, so square root of tsaka. Ano ba yung 1.2? Concentration ng acid natin. Ka. Di Ka. Tsaka. Okay? So, yun yung technique namin dito. Okay? So, square root of tsaka. Sir, paano po pag hindi given yung Ka? Kapag hindi given yung Ka, no? So, di ba may listahan tayo ng Ka dito last time? Ito. So, pwede nyo tignan itong mga table na to. So, dito kasi nakalista yung mga Ka values natin. Given to, don't worry. No. Hindi pwedeng hindi given yan kapag pinapasolve yung equilibrium concentration. Okay. So, naka-table naman sila. So, pwede nyo i-check dito kung ano yung value ng Ka. Then, yung concentration ng acid, that must be given as well. Okay? So, again, when we solve for the equilibrium amounts, tas pasok siya sa small x approximation criteria, pagpasok siya dyan, then the x value is just the square root of tsaka. Yun na yan. Okay? Which is 0.029, the same answer we got last time. Diba? Bilis, diba? Siguro nagko-quadratic tayo, hindi pa tayo tapos until now. Pero tapos na tayo eh. Yun na yung x value. Pero your problem doesn't end there, no? X pa lang nakukuha mo. Hindi mo pa nakukuha yung final answer dito. So for the equilibrium amounts, dun mo na siya ipa-plug in dito sa table. So H3O plus will be 0.029 molar. Nitrite ion will be 0.029 molar. And for nitrous acid, that's 1.2 minus X. That will be 1.171 molar. Just like what we answered last time. Okay. Di ba, bilis? Again, kailan mo pwede gamitin yung small x approximation? If the ratio of the concentration of acid and the Ka is greater than 1,000. Okay. Pagpasok yun doon sa ganung criteria, then the x value can just be obtained by obtaining the square root of tsaka, the concentration of acid times the Ka. Ayun lang. However, itong mnemonic na to, yung tsaka na to, Tsaka talaga, no? Yung tsaka na yan, mag-work yan if your coefficients is 1 lang. 1 lang yung coefficient nila lahat. Pero kapag kunwari may 2 dyan, may 3, hindi nagagana yung square root of tsaka. Sundin mo na lang kung ano yung lalabas dito sa equation mo na to. Okay? So, ganun lang. Tapos na. Let's try other items. Let's apply this knowledge. Kasi sabi ko nga sa inyo, starting from now, yung ating problems sa Anachem, puro ganito na. Puro equilibrium na. So, basta alam niyo yung square root of tsaka, madali na lang yung titration. Yun kasi next chapter natin after the midterm exam. Okay? So, ganun. Proceed tayo dito. Let's try this problem. Let's see if we can use the square root of tsaka or the small x approximation. By the way, typo to. KB yan. Okay? That's KB. Na-typo lang. Calculate the equilibrium hydroxide concentration from 0.075 molar of ammonia. The reaction of ammonia with water is given. They will produce ammonium ion as the conjugate acid. And hydroxide is the conjugate base. No? Okay. The Kb, or the base dissociation constant, is 175.5. Let's check if we can use the square root of tsaka. No? Kaso in our case, no, pag acid, tsaka yan. Pag base yan ay CbKb. Concentration of base then Kb. Yun lang yung counterpart niya. Again, kapag acid, ang small x approximation ay tsaka. For base, ang small x approximation, ang tawag dyan ay CbKb. Ang Captain Barbell. No? Okay. So, yan. Tignan natin if we can use the small x approximation. Ano gagawin ko? I will divide my reactant concentration with the K. Okay, so concentration of base divided by the Kb. So that will be 0.075. 175 times 10 raised to negative 5. Tignan mo if yan ay greater than 1,000. Divided by 175 times 10 raised to negative 5. So the ratio is 4,285, which is greater than 1,000. So qualified tayo. So you can use the small x approximation. Pwede tayo gumamit ng small x approximation. Okay? So yan, alam natin we can use the small x approximation. Ano susunod mong gagawin? The usual. Fill out mo yung ice table, sulat mo yung K, no, yung K expression. Fill out natin yung ice table. We have NH3, NH4+, OH-. Initial concentration ng ammonia 0.075. Walang sinabi about the others. So 0 sila. So since 0 sila, positive sila. Negative ito. And at equilibrium, combine I and C. Tapos anong gagawin mo? You plug this into your K expression. In our case, KB. On numerator, X and X ulit yan. On your denominator, you have 0.075 minus X. Again, sabi natin, this problem qualifies sa small x approximation. That is, we can remove itong minus x sa denominator. Okay? Kasi kapag hindi natin yan tinanggal, magko-quadratic equation tayo. Ayaw natin yun, di ba? As much as possible, ayaw natin kasi nakakapagod. So, yan. So, since qualified naman siya sa small x approximation, then pwede natin burahin itong nasa baba. Itong minus x na yan. Okay? Yan. So, burado na siya. Then, you solve for x. That's x squared equals 0.075 kb. Yung cross multiplication. Solve for x, square root of concentration of base times the kb. Okay? CBKB. Di ba? Easy. Ang bilis na. Pag na-master nyo na to, you can answer the problem within 1 minute lang. So, x is 1.15 times 10 raised to negative 3. Hindi dyan natatapos, ipa-plug in mo pa yung x. So, x is 1.15 times 10 raised to negative 3. Excuse me. May alikabok dito. So, 115 times 10 raised to negative 3. Then, for the NH3 concentration at equilibrium, divide mo na lang, subtract mo na lang yan. So, that's 0.0739. Okay? So, yan. So, ganun lang. Tapos na tayo sa problem. Wala na tayong iintindihin about symbol lab, paano i-plug in yan sa calculator. No more. Ganun na. As long as your problem qualifies sa square root sa small x approximation natin. Okay? So, ganun lang. So, for acids, kapag pasok yan sa small x approximation, x is equal to the square root of tsaka. For bases, if pasok yan sa small x approximation, x is equals to square root of CBKB. Provided that the coefficients for all the chemical species is 1. So, ganun lang. Tapos na. Wala na akong masasay. Yan na yun. How about this problem? Kaya ba natin to sagutan with the small x approximation? Tignan natin. So, looking at Ka, negative 5 yan. So, okay. Pero, check natin. If we divide the concentration of the acid, so ito yung acid natin. So, ito yung acid natin. Kapag dinivide natin yan sa Ka, so that's Chap over Ka, no? Is that greater than 1,000? Yung kasi yung pinaka-final say, no? Tignan natin kung yan ay greater than 1,000. Okay, so the ratio is just 8. Hindi tayo pwede dyan. Hindi pwede square root of tsaka. So, ibig sabihin, you have to use quadratic equation. Okay? Sad life na. Hindi natin siya pwede gamitan ng shortcut. So, quadratic equation kapag ganun. Okay? So, hindi ko na to sasagutan. Kayo na bahala magsagot dyan. Okay? So, para ma-practice kayo sa quadratic. Pero again, yun nga. If you can use the small x approximation, please use it. No? Again, ano yung criteria para magamit yan? You check if the concentration of reactant over K is greater than 1,000. If that's the case, you can remove the negative x term in the denominator. So that x will just be the square root of the concentration times the K. Katulad ng mga ginawa natin sa dalawang examples. Ayan, tapos na. Okay, so yan, let's proceed with the next part. Let's talk about percent ionization naman. Okay, so since there are two types of electrolytes, that means magkaiba tayo ng ionization for each category. For strong electrolytes, sabi natin, the ionization is 100%. No? So if you have a strong acid, look at this graph. If you have a strong acid, then the ionization is complete. 100% ionized yan. However, if you have a weak acid, sabi natin, it equilibrates. No? Meaning, only portions of our acid will dissociate. So, onting amounts lang yung madidissociate. Okay? So, what is percent ionization? Percent ionization tells us by how much nag-ionize yung iyong reactant, no? Anong percentage niya yung naging ions? And the percent ionization for acid can be calculated as this. You have your ionized acid at equilibrium. That means that's the concentration of the H plus at equilibrium divided by the initial concentration of your acid or the HA, yung given na amounts, times 100. So for weak acids, the percent ionization is low, no? Mababa lang yung mga percent ionization nila. One example would be the acetic acid, yung suka, that's just 5%, no, ionized. Ibig sabihin, yung inyong natitikmang asim sa suka, 5% pa lang yon sa kung gaano ka-asim mismo yung acetic acid. Okay? So, I happen to encounter acetic acid na glacial yung form. Ibig sabihin, mataas yung ionization niya. Sobrang tindi ng asim nun. No? Walang-wala yung mga suka sa mga pouch na dato puti, no? 'Di ba yung suka doon parang normal lang. Pero yung suka kapag mataas yung ionization niya, as in gumuguhit siya sa lalamunan mo. Okay? So ganun. Um, binuksan ko lang yung takip nun eh. Onting bukas lang. Amoy suka lahat yung buong kwarto eh. Ganun katindi yung asim. So, ibig sabihin dun sa inyong panluto, 5% pa lang yon ng tunay na asim ng suka, no? Okay. So bakit 5% lang? Kasi nga weak acid yung acetic acid, no? Kasi may resonance yung ating molecule. Kaya stabilized siya, hindi agad siya nag-ionize. Okay? Na-share ko lang. Okay? So yan. So again, for weak acids, the percent ionization is always less than 100%. For strong acid, it is always 100%. No? To compute for the percent ionization, that is just the concentration of H plus at equilibrium divided by the concentration of your acid initially times 100. Let's try this problem. Calculate the pH and the percent ionization of, I forgot yung molarity. Lagay ko yung molarity, 0.5 molar. Kalimutan ko i-type. So calculate the pH and the percent ionization of 0.5 molar acetic acid. The Ka is given. So I want you to try to answer this now. Maybe I'll give you 5 minutes to accomplish this. 5 minutes lang kasi habang nagdi-discuss ako mamaya, pwede nyo naman ituloy yung pagsagot niya. So I'll give you a head start, 5 minutes para matry nyo if you can use the small x approximation. So I'll be back by, anong oras na? 11:07. Balikan ko kayo kung kumusta na kayo. Okay, so you check first if you can use the small x approximation, then complete the ice table, solve for x, solve for equilibrium amounts, and answer the two questions. What is the pH and the percent ionization? So I'll be back. No? So good luck. Sagot muna kayo. Okay, so nagbabalik tayo. Question, can we use the small x approximation? Anyone? Ayan, so yes, we can use the small x approximation because 0.5 divided by 1.8 times 10 raised to negative 5 is that's 27,000. No? So, ibig sabihin, qualified talaga siya for the small x approximation. So, madali na lang to. X is equal to the square root of tsaka. So, x value is square root of 0.5 times 1.8 times 10 raised to negative 5. Or 3 times 10 raised to negative 3. Matapos agad. hindi na tinapos yung ice table eh. No? So, yan. Alam mo na yung x value agad. Pero sige, complete natin tong ice table. So, kunwari, given ka lang neto, how are you going to write the dissociation reaction for that? No? So, to write the dissociation reaction of your acid, just simply remove the H. No? Yan. Tatanggalin mo lang yung H and then whatever is left, yun yung iyong conjugate base. No? So, you have your CH3COOH. You can dissociate that as H plus and CH3COO minus. Ayan, pwede na yan. Tatanggalin mo lang yung acidic H. So, this will be your conjugate base. This is your conjugate acid. Okay? So, ganun lang. So, initial is 0.5. Walang sinabi about the others. Positive sa others. Minus sa acid. So, 0.5 minus x, x, then x. We already know x because that is just the square root of tsaka. Okay? So, we already know the value of x. So, pa-plug in na natin. So, H plus is 3 times 10 raised to negative 3. H, the conjugate base is the same. Okay, same sila ng molarity. And for our acid, that's 0.5 minus 3 times 10 raised to negative 3. We get 0.497. So that is their equilibrium concentrations. Diba? Wala pang 1 minute, tapos agad na. Ganun lang. Basta pasok yan sa sa ating small x approximation. Then x is just the square root of tsaka, if that's acid. O kaya kapag yan ay base, that is the square root of CbKb. Tapos na. Since you already know the equilibrium concentrations, let us try to answer the question talaga sa problem. Calculate the pH and the percent ionization. So to calculate for the pH, ganito. pH is negative log ng concentration ng H+. Okay? So again, pH is negative log of the concentration of H+. Anong concentration ng H+? That is the concentration... Nag-alarm ulit. Napindot ko pala repeat. Okay. So anyway, so yung concentration ng H+, that pertains to the equilibrium concentration. Okay? So hindi yan yung concentration ng acid mo. That's the equilibrium concentration of H+. Magkaiba yan ha. Baka kasi ito yung i-plug in nyo doon. No. Ito dapat yung equilibrium concentration. So again, pag nakita nyo pH, that will tell you the equilibrium concentration of H+. So paki-plug in yung concentration ng H+. It's 3 times 10 raised to negative 3. Kunin natin negative log niyan. So the pH is 2.52. Medyo maasim yung solution natin. So that's the pH of the solution. How about the percent ionization? So kanina, percent ionization is given as the concentration of H plus divided by the initial concentration of your acid times 100%. So that will be 3 times 10 raised to negative 3 divided by 0.5 times 100%. The percent ionization of this species is 0.5 times 100. So that is equal to 0.6% ionization. Only 0.6% of our original amount ang nag-ionize, no? Okay. So ganun lang. Just a few portion of it ionized. Okay? So yan. Ayun na yan. Okay? Try this problem. I want you to read this, then I want to hear some comments about this. Ang unang question ko, kaya ba natin sagutan tong problem na to? So, basahin natin yung problem. Ayan, lobat ako. So, let's read the problem. Calculate the Ka and the percent ionization of an acid, Ha, given that 0.70 molar of Ha has a pH of 4. If you are given an arbitrary acid, HA tawag namin doon. Arbitrary acid yan. So, HA will dissociate as H plus and its conjugate base. Okay, so yan yung kanyang dissociation reaction. Will we be able to answer this problem? Tignan natin. So, gawin natin yung ice table. So, we have HA, H plus, A minus. So, initial concentration ng HA ay 0.7. Walang sinabi about the others. Positive yung others, minus yung HA. So, at equilibrium, HA is 0.7 minus X, and the others ay X. If you plug it into your Ka, that will be X times X in the numerator. And on the denominator, that will be 0.75, 0.7 lang pala. So that will be 0.7 minus X. Will we be able to solve for this problem? Kaya ba natin hanapin yung Ka and yung percent ionization niya? So I want you to double check the problem. I want to hear some words. Pwede kayo mag-raise ng hand if you have any clues about this problem. Meron kasi diyang info that will help us solve this problem. Ano kaya yung info na gusto ko marinig sa inyo? Yes, let's have Patricia.
Pwede natin mahanap yung concentration ng H4 with pH, di ba?
Ayun. So, correct si Patricia. Di ba sabi ko kanina, in-emphasize ko nga siya kasi ito yung susunod, no? So, in-emphasize ko kanina that the concentration of your H plus corresponds to the pH of your solution. Ibig sabihin, kung alam mo yung pH, alam mo yung concentration ng H plus at equilibrium. So basically, alam mo yan. So since alam mo yung X, alam mo na rin yung value niyan, and alam mo na kung ano yung magiging equilibrium amounts nun. Diba? Amazing. So again, yung pH natin, that will help us, no, to answer this problem, to solve for the Ka and the percent ionization. Because the pH will correspond to the X, no, doon kay H plus. And once alam mo na yung amount ng H plus at equilibrium, that is equal to X, alam mo na rin yun sa conjugate base. And at the same time, malalaman mo na rin yung final concentration ng HA at equilibrium. Okay? So, di ba, isang info lang, ito lang, nasagutan na natin yung tatlong equilibrium items, no? So, ganun. So, gawin natin, let us convert the pH into H+. Okay? So, paano yon? Antilog yon. So, that's 10 raised to negative pH equal yon sa concentration ng H+. Or H+ is equal to 10 raised to negative 4. Ganyan na lang yan, 10 raised to negative 4. So, since I know may ano na, drawing ko lang tong green circle ko kanina. Okay, so since I know the equilibrium concentration of H+, that corresponds to X as well. So, alam ko na yung equilibrium amounts ng aking species. Diba? So, this will be 10 raised to negative 4 molar, 10 raised to negative 4 molar, and this will be 0.7 minus 10 raised to negative 4 molar. O, diba? Yan na yung kanilang equilibrium concentrations. Then to solve for Ka, you just simply plug in your values. So that will be 10 raised to negative 4. Then another 10 raised to negative 4. So yung isa yung sa H+, yung isa sa conjugate base. And yung nasa baba, that will be 0.7 minus 10 raised to negative 4. What will be the Ka? So the Ka is 1.43. 1.43 times 10 raised to negative 8. O, diba? Galing, no? As long as you know kung ano yung ating pH, nalaman mo na yung H+ at equilibrium, and since that corresponds to X, alam mo na rin yung iba. So since alam mo na yung equilibrium amounts nila, you plug it in your Ka, you get your Ka value, di ba? So ito yung mga mga moderate type questions, no? So expect some of this sa inyong quiz pa sa exam, no? So yan, galing, no? How about the percent ionization? So for the percent ionization, that is the H+ at equilibrium divided by the HA initially times 100%. So that is 10 raised to negative 4 divided by 0.7 times 100%. The percent ionization is 0.014%. Masyadong maliit lang. Diba? Ganun lang. Basta ang tip ko lang sa inyo dito is ganito. Kailangan alam nyo kung ano yung mga meaning ng mga numbers dito. Ano meaning ng pH? Yan yung H+ concentration na nakalog lang, naka-negative log lang. So, ganun. Another type ng question na ganito yung approach is, instead of saying the pH, so instead na yung pH ang ibibigay niya, sasabihin niya doon, given that 0.7 molar of HA has a percent ionization equal to 5%. Kunwari, ganun yung problem. So, instead of pH yung binigay, ang binigay sa inyo, percent ionization. So, remember nyo yung formula ng percent ionization, that's H+ over the initial amount of your acid. From this equation, pwede mo makuha yung H+. And that will correspond to your X value. Sa-substitute mo na lang yon doon. Okay? Pwede rin naman, kung hindi pH ang binigay, pwede POH. So, from POH, pwede mo yun i-convert into pH. No? Then, pwede mo makuha yung X dito sa table natin. So, ganun yung ganun yung tatlong typical approach sa ganitong problem. Pwedeng pH yung ibigay, kunin mo yung H+ doon. Pwedeng ang ibigay ay percent ionization, kunin mo rin yung H+ doon using this equation. And also, pwede rin yung POH. Convert mo siya to pH, then kunin mo yung H+ doon. Okay? So, as long as they are mathematically related, kaya siya sagutan. Diba? So now let's proceed, no? Ito medyo ibang topic na tayo. Okay. So what will happen if you have an acid and a conjugate base sa inyong system? No? Suppose meron tayong ionization constant for the acid and the ionization constant for your base or the conjugate base, no? So yung acid natin that will dissociate as H plus and A minus, and yung ating conjugate base, that's A minus reacting with water will give us OH plus HA. If we combine the two equations, the acid equation and the base equation, okay, so acid equation plus the base equation, pag pinagsama mo yan, magka-cancel out yung yung mga base mo, pati yung acid. So again, yung yung equation mo ng acid and yung equation mo for base, pag pinagsama mo sila, yung acid and base, pareha sila maka-cancel out, leaving you the ionization of water. So meaning yan, ang Ka pati yung Kw, they are related, no? Recall that when we combine equations, we multiply the Ka, 'di ba? Sabi sa lecture. Pag pinagsama yung dalawang equation, we multiply the Ka's, no? So we get Ka times Kb equal to Kw, the ionization constant of water. So saan natin 'to magagamit? Kunwari, may binigay ako sa inyong problem. Ka yung binigay ko, pero ang kailangan nyo ay Kb. You convert Ka to Kb lang. How? You use this now. So to convert Ka to Kb, the equation to be used is Kb equals Kw over Ka. O kaya, kung gusto mo naman ng Ka from the Kb, then that is Kw divided by Kb. Okay? So you can get the value of Ka from Kb and vice versa using this equation. Okay? So ganun lang. Parang ito rin yung pH, 'di ba? Ito yung sa H, ito sa OH, equal siya sa water constant. Okay? So however, in our case, equilibrium constant nilagay natin. Okay? So ganun lang. Just in case, kunwari, sabihin ko, the Ka of this acid is ganito. Calculate for the Kb. Or you just divide your your ion product of water by the given K value. Hindi na ako magbibigay ng example dyan, no? Kasi divide mo lang naman. Okay? So sa worksheet na lang. Okay. So let's proceed with the next one. So if you notice, no, kanina pa, ang meron tayo ay puro monoprotic acids. When I say monoprotic acid, isa lang yung H plus nila. Totoo ba yung sinabi ko na yan? Tignan nyo yung mga previous problem na sinagutan natin today, ha? Ilang H plus yung mapoproduce dito? Isa lang. Okay? Dito, isa lang din. Okay? So, ibig sabihin, yung mga previous problems natin, kunwari ito, isang H plus lang din na produce. Dito, isang H plus lang din. Okay? So you can see, yung ating mga sagot natin kanina, puro isa lang yung H plus nila. So, ibig sabihin, they are monoprotic acid. Isa lang yung H plus. However, there are other types of acids. We call them the diprotic acid and the triprotic acid. So, hanggang triprotic acid lang ang limit. Okay? So, yan. So, ano yung difference nila with the monoprotic acid? So since they have multiple H+, ang dami nilang H+, ibig sabihin kaya nila mag-produce ng maraming ganun. However, the ionization of your protons, of your H+, is a stepwise process. Ibig sabihin, step by step yung pagtanggal ng H+. Suppose we have this equation here, carbonic acid, dalawa yung acidic H niyan. So, yung pagtanggal natin ng H dyan, isa-isa lang. So, una, tatanggalan mo to ng H. Then you will be left with bicarbonate ion. Then after nun, yung bicarbonate, yun na yung tatanggalan mo ng isa pang H, leaving you the carbonate ion. So, if you have a diprotic acid, how many steps ang kailangan para matanggal yung mga protons? Dalawa. So, this is the first step and the second step. No? So, kapag diprotic acid, 2 times yung dissociation. Pag triprotic acid kaya, okay, so suppose we have H3PO4. Ilang steps yan pag phosphoric acid? Di tatlo kasi tatlo yung H natin. So we will release the first H plus and then we will be left with dihydrogen phosphate. After nun, yung dihydrogen phosphate naman yung matatanggalan ng H, giving us biphosphate. And then lastly, yung biphosphate, yun naman yung matatanggalan ng H, no? So you will be left with phosphate anion. Okay? So ganun. So depending on the number of H in your acid, ganun karami yung steps, no? Again, stepwise 'yan, hindi agad-agad 'yan natatanggal, no? Stepwise ang removal ng H+. And since stepwise 'yan, that means for each steps, no, there is an ionization constant for each step, no. Ibig sabihin, iba yung ionization constant for this step and iba din yung sa nasa baba. Ibig sabihin, if you're going to calculate for the equilibrium concentration of carbonate, dadaanan mo muna to, then ito. So 2 times ka mag-ice stable. That's why shinare ko yung small x approximation. Because in the next chapter, chapter 5, sa acid-base titration, babalikan natin to. Okay? So, kunwari, given ko ito, pinapahanap ko ito. So, mag-ice stable ka muna dito, then another ice stable dito. So, 2 times ka mag-ice stable. Kaya doon nagiging handy yung small x approximation. Okay? So, ganun lang. Paano na kung phosphoric acid yan? 3 beses ka mag-ice stable na. So, ganun. So, yan. Ano na lang yan. Sa next chapter na natin to, hihimayin talaga, no? But the idea here is that if you have a diprotic acid, you will have 2 steps of ionization. And each step will give you a different K value. Ganun din kapag triprotic acid. 3 steps naman. Okay, so that means 3 different K values. So we will come back to this by next chapter. That means around next week pa yon. Tagal pa. So ito, in this table, we have here the ionization constant of some diprotic and triprotic acids. So for sulfuric acid, this is the only diprotic acid in which its first ionization is complete. No. So sabi dito, the Ka is very large, meaning this is 100% ionized. So you can calculate for the amounts of H plus and HSO4 by stoichiometry na lang. Kasi yung first ionization niya is very large. No? Ibig sabihin nun 100%. However, if you do the second ionization to produce H plus and SO4 minus 2, dun ka na mag-ice stable. Okay? So, ganun. So, sulfuric acid is the only diprotic acid which has the first ionization that is complete. Then, yung second ionization, ito na yung ice stable. So, here are the other Ka values for other acids. No? Mapapansin mo for the other acids, you have no choice but to use the ice stable talaga. And the small x approximation. Especially for phosphoric acid, tignan mo, 3 yung kanyang K values. Okay, so ganun lang. Ayun, so yun na yan. So babalikan natin tong topic na yan pagdating natin sa titration. Okay? So for now, punta muna tayo dito sa topic natin, last topic natin today. So let's talk about buffer solutions. So I know familiar kayo sa buffer. Ano idea natin kapag buffer? These are solutions that resist gradual changes sa pH. No? Okay? So marami tayong buffer systems in our body. Kasi imagine nyo, if ang body natin ay walang buffer, uminom ka lang ng pineapple juice o kaya makainom ka lang ng suka, deads ka na. Why? Mataas yung pH nila eh. So imagine without buffer systems in our body, if you drink acidic or basic substances, you're dead agad. No? Huminga ka lang, patay ka na agad. No? Kasi yung ating hininga, may carbon dioxide yun. No? Ibig sabihin, acidic yun. No? So without any buffer systems, hindi tayo mag-exist. No? So anong ginagawa ng buffer system? So the buffer system, they try to maintain the pH to a tolerable level. So maintain niya yung pH to a tolerable level. Ibig sabihin yan, dagdagan mo yan ng acid, dagdagan mo yan ng base, hindi yan agad magbabago. And that is why our body contains lots of buffer systems. No? Ang dami natin buffer system sa body. Okay. Kasi what happens is that kapag biglang nagbago yung pH mo, yung iyong proteins, no, yung inyong cells, pwedeng mamatay agad, no? Pwedeng masira yung proteins. Okay? So for example, at different pH, no, yung inyong red blood cell, pumangit yung itsura niya, no? So ganun. So hindi na siya magpo-function. You will die of oxygen starvation. Pag ganun. So yun yung mga side effect, no, kapag wala tayong buffer sa ating body. Okay? So yan, buffer systems are solutions that prevent the gradual changes in the pH. No? Pinipigilan niya yung biglaang pagbabago sa pH when you add acids or bases. And ano yung composition ng ating buffer? So the buffer is composed of a weak acid and its salt o kaya weak base pati salt nun. Okay? So ano meaning ko sa salt, no? Punta tayo dito sa isang slide. Okay. So punta tayo dito. So this solution here, this mixture here is a buffer mixture. Bakit? You have the weak acid. Ito. This is your weak acid. And then itong isa, this is your salt, no? Salt of the conjugate base. So kailangan sa buffer solution, may weak acid ka and the salt of the conjugate base. So basically, parehas lang yan halos ng formula. Yung H, papalitan mo lang ng metal. Usually sodium and potassium. Okay? So same lang sila ng formula, pero yung isang H, palitan mo ng sodium o kaya ng potassium. You now have your salt of the conjugate base. So pag pinagsama mo yung dalawang yan, they will together resist the changes in pH. No? Pipigilan nila yung gradual change sa pH ng solution. O kaya if you have a weak base, kailangan meron kang salt of the conjugate acid. Okay? So if you have a weak base, you must have a salt of the conjugate acid. So one example will be ammonia, that is a weak base. And ano yung salt ng conjugate acid natin? Or you just add H+. Pwedeng ammonium chloride, no? So that's the common. So this is the salt of the weak base. So ganun lang. You must have either of these two. No? That will give you the buffer system. So ngayon, punta muna tayo sa math. Okay, mag-math muna ulit tayo. So given the reaction of your acid, you get your Ka. So this is the Ka of the acid dissociation. Okay, so this is the Ka of your acid dissociation. What I did here sa baba is that I isolated my H+. So nilipat ko yung H+ on the other side. So I rewritten the equation. And then I get the negative log, no, of the both sides of equation. Pag kinuha mo yung negative log ng both sides of the equation, so ito, magiging negative log h plus yan. Then on the right side, ano mangyayari dito? So according to the rules of logarithm, log a times b, mag-split sila kapag nilog mo. So that will be log a plus log b. However, in our case, negative log tayo. So negative log a minus log b. Kaya nag-split yung ka pati yung ha. Kasi naka-multiply sila. So yan. So we get this and this one. So itong fraction, hindi na natin pinaghiwalay pa. Okay, so pinagsama na lang natin sila. So ano yung purpose na ito? Ganito. What is negative log h plus? That's the pH. The negative log ka is the pKa. No? Basta negative log, may letter p sa harap. Kaya pH, POH. Then ito, pKa. No? And for this one, we retain the negative log na lang. No? This equation is called the Henderson-Hasselbach Equation. So ano purpose na ito? The Henderson-Hasselbach Equation will tell us what should be the amounts of your acid and the conjugate base so that you can prepare a certain pH. No? So you can prepare your buffer solution at a certain pH. So this equation is useful kapag kayo mag-work sa buffer solutions. No? Kunwari, you are working with enzymes or bacteria. So their activity is dependent on the pH. No? So a friend of mine worked with enzymes, no, sa kanyang thesis. Ako kasi material science ako nun, no. So siya naman sa enzyme siya. So enzymatic activity. Ginawa niya doon yung kinultivate niyang enzymes, no. Tinabi niya sa certain pH para optimum yung activity ng enzyme na yon. Okay. So sa inyo sa medtech, most likely gagawin niyo rin 'yan in your future subjects, no. I don't know if sa clinical chem may ganyan. Gagawa kayo ng buffer solutions to maintain the pH of your enzyme o kaya ng bacteria that you are cultivating or yung focus ng study niya. So, para makagawa kayo ng buffer, you will use the Henderson-Hasselbach Equation. This will tell you ano ba dapat yung proportion ng inyong acid and the conjugate base para makagawa ka ng pH, no, ng certain pH from your buffer system. Okay? So that's the Henderson-Hasselbach equation. Other forms of the Henderson-Hasselbach equation ay ito, pH equals pKa plus log conjugate base over the acid. So that's one version. Ginawa lang dito, yung sign ng logarithm pinalitan. When you change the sign of the logarithm, the fraction reciprocates. Bumabaliktad yung fraction. Nasa rules yan ng log e. And then the counterpart of this equation is the basic equation. So, ano yung counterpart ng pH? POH. Ano counterpart ng Ka? The pKb, the base constant. Plus log. Ano counterpart ng conjugate base? The conjugate acid. And ano yung counterpart ng acid? Yung base. No? So this is the base counterpart of the Henderson-Hasselbach equation. Ito yung base version. Ito yung acid version. So depending on your problem, you can use either of the two, no, para ma-determine nyo ano ba yung dapat na amounts ng inyong salts para makakuha kayo ng certain pH. Itong Henderson-Hasselbach equation, this is an equation that we will use thoroughly next chapter. So supposedly next chapter pa talaga to, pero I want you to be introduced sa idea na to para you have more time to practice, no? Okay, para mas marami kayong chances na makabisado to so that when we are on the chapter 5 na, madali na lang sa inyo gamitin tong Henderson-Hasselbach. Okay? So chapter 5 pa talaga to pero idinamay ko na para advanced, no? Okay, so yan. So this is the Henderson-Hasselbach equation. This will tell you kung ano dapat yung ratio ng inyong salt and ng acid or base. That will give you the certain pH. Okay, so let's try to answer this. What is the pH of a solution containing 0.30 molar formic acid and 0.52 molar potassium formate? By the way, hindi na natin kailangan ng ice table. Graduate na kayo dito. Kasi pag buffers, wag nyo napapansinin yung ice table. Ha? Graduate na kayo dyan. So again, what is the pH of a solution containing 0.3 molar formic acid and 0.52 molar potassium formate? So check mo muna, ano ba meron ka? Yung formic acid, this is a weak acid. And ano yung potassium formate? O, tignan mo yung equation. Anong pinagkaiba nila? Yung H naging metal. So ibig sabihin, ito yung salt ng acid. So ito yung salt of the acid. Or basically, ito yung conjugate base natin. So you have a mixture of a weak acid and a conjugate base in the form of salt. Ibig sabihin, we are pertaining to buffer systems. No? So kapag may buffer system ka, you have to use the Henderson-Hasselbach equation to get the pH. For acid, the Henderson-Hasselbach equation is pH equals pKa plus log of the concentration of the conjugate base divided by the acid. So, ang hinahanap natin pH. So, yung concentration ng conjugate base given na 0.52. Concentration ng acid given na 0.3. So, ipa-plug in mo na lang yun dito. The question is, ano yung pKa mo? Ano yung Ka ng formic acid? So, if you could still remember, may table akong pinakita kanina that lists all the acid and their corresponding Ka values. So, ayan. Nandito siya sa PowerPoint natin. So, we have this table of some weak acids and their ionization constant. So, for formic acid, the Ka is 1.7 times 10 raised to negative 4. So, yun yung gagamitin natin to solve for the pKa. 1.7 times 10 raised to negative 4. So again, Ka is 1.7 times 10 raised to negative 4. Paano mo kukunin yung pKa? Ano yung sabi ko kanina? Basta may letter P, may negative log yon. Okay? So that's just negative log of the Ka. Uh, 1.7 times 10 raised to negative 4. So solve natin yung pKa. That's 3.77. Okay. So pKa is 3.77 plus logarithm concentration ng conjugate base, which is 0.52, and the concentration of your acid, 0.30. So what will be the resulting pH of this solution? Pindutin nyo na lang sa calcu. The concentration of the acid is 4 or 4.01. Okay? So yan. As long as you know the concentrations of your acid and the conjugate base, you can get the pH of your resulting solution. So kunwari, you are asked to prepare a pH for solution. Ang gagawin mo, magpe-prepare ka ng ganitong concentration and ganyang concentration ng acid. So pag pinaghalo mo yon, automatic pH 4 agad yon. Okay? And that will resist the gradual changes sa pH. So if we look at this graph here, kapag water lang yan, you add acid, drastic ng change sa pH, no? Isang patak lang yan, bagsak agad yung pH. Ibig sabihin, super acidic agad. However, if you have a buffer solution, kahit dagdagan mo yung acid mo, as around constant value lang siya. Hindi siya ganun kalaki yung changes niya. Okay? So, ito yung concept ng titration actually. So, ganun lang. So, that's how we use the Henderson-Hasselbach equation. As long as you know the concentrations of your acid and your conjugate base, you can get the pH of the solution. Sa ngayon, practice muna tayo. Paano natin malalaman yung buffer system? Okay. So, let's identify which of the following are the buffer systems. So, we have A, KF, HF. We have B, KBr, HBr, and we have C, Na2, CO3, NaH, CO3. So, dadagdagan ko yan, H3PO4, and sodium phosphate. So, of the four solutions, of the four mixtures dito, alin dyan yung magbibigay ng buffer system? Ano yung requirement ulit kapag buffer system? Kailangan may weak acid ka plus conjugate base. No? Basta may acid ka and the conjugate base, you have a buffer system. Okay? So, yan. So, let's try letter A. Is that a buffer system? Buffer system kaya to? Tignan natin. Ganito. You identify first which of the two is the acid. Malamang, ito yung acid. HF. So, that means this one could be the source of your conjugate base. Anong ions yung magagawa mo sa KF? You have your K plus and the F minus. Diba sabi ko sa inyo kanina, yung potassium and yung sodium, yun yung pwede ipalit sa H kapag gagawa tayo ng conjugate base. No? So you just disregard the K plus and you compare this ion with your HF. Are they related? Pag sinabi kong related, sila ba ay conjugate acid-base pair? So are they related? Are they conjugate acid-base pair? The answer is yes. No? They are conjugate acid-base pair. Bakit? Kasi, ano ba yung relationship ng dalawang yun? Yung conjugate acid, that is just one hydrogen less than your acid. So, isang H lang yung nabaklas sa kanya. So, that means kung ito yung acid, ito yung formula ng conjugate base, F minus lang. So since you have an acid and a conjugate base, then you have a buffer solution for letter A. So that's a buffer system. How about letter B? We have KBr and HBr. Obviously, HBr yung acid. So that means your KBr could be a source of your conjugate base. So split mo siya into ions. So you have the K plus, the Br minus. Again, yung sodium and potassium, wag nyo sila pansinin. Just focus on the anion. Are the two related? Sagot ay yes. No, they are related. They are conjugate acid-base pair. Bakit? Kasi isang H lang yung difference nila. Yun kasi yung key sa conjugate acid-base pair. Yung isa may H, yung isa nabawasan ng isang H. No? So you have the acid, you have the conjugate acid here. Then that means KBr, HBr mixture is a buffer solution. How about letter C? Ito medyo hindi obvious, no? Buffer kaya yan? Di natin sure, no? So, ganito gagawin natin. So, since we both have salts, no? Tanggalin natin lahat ng metals. So we have Na2 carbonate and we have sodium bicarbonate. Split natin yan into ions. Anong magagawa natin? We have Na plus, CO3 minus 2, and we have Na plus and bicarbonate ion. So ano sabi ko, yung mga metals, sodium, potassium, burahin. So you're left with bicarbonate and carbonate. So sa tingin nyo, sino sa dalawa yung pwede mag-act as acid? E di yung may H, no? Yung mas marami yung H. So this can serve as an acid. Ano to? Is that related to that one? Is that related to your acid? Yes, no? So carbonate is the conjugate base of bicarbonate ion. Bakit sila naging conjugate acid base pair? Kasi tignan mo, isang H lang yung difference nila. And as I told you earlier, pag isang H yung pagitan, buffer lang yan. Ano yung conjugate acid base pair yon, aka buffer solution yan. So ibig sabihin, at home, you can prepare buffer solutions. Bili kayo ng baking soda, pati baking powder. So yung baking soda, sodium carbonate yon, baking powder, that's sodium carbonate. Paghaluin mo yung dalawang yon, buffer solution na yon. Okay? So ganun lang, ka-easy. Kaya ito gawin sa bahay. Although wala tayong pH meter, kaya hindi natin talaga masasolve. Okay. So this one is a buffer solution. How about letter D, yung dinagdag ko? Dito na lang. Wala na akong space doon. So for letter D, I added H3PO4 and sodium phosphate. So let's check if the mixture is a buffer mixture or hindi. Alamin mo, sinong acid? Ito yung acid ko. Obviously, siya yung maraming H eh. How about sodium phosphate? Tignan mo kung yan yung source ng conjugate base mo. So you will produce Na plus and PO4, negative 3. Compare. Are the two related? When I say related sila, that means conjugate acid-base pair sila. Ang tanong, conjugate acid-base pair ba sila? Anyone? Are they related? Are they conjugate acid-base pair? Ang sagot ay hindi sila conjugate acid-base pair. Bakit? Kasi sabi ko kanina, if conjugate acid-base pair yan, isang H lang yung difference nila. Okay? So isang H lang yung difference dapat nila. Ilang H yung pagitan nila? Tatlo. No? So tatlo. So, ibig sabihin, hindi sila related to one another. So they are not the conjugate acid-base pair. So ibig sabihin, this mixture is not a buffer solution. So ganun yung gagawin nyo para malaman nyo kung anong chemicals yung pwede gamitin to create the buffer solution. Kahit ano, pwede gamitin. Pwede yung suka. Pwede yung pwede yung suka. Pwede yung sulfuric acid din. Pwede, basta may Ka, no? Basta may Ka, may conjugate acid, may base. Or conjugate base merong acid. Basta may relationship silang dalawa, you can create buffers out of them. Okay? Ang kailangan mo lang tignan is if sila ba ay conjugate acid-base pair talaga. Pag sila ay pair, then pwede ka makagawa ng buffer. However, pag hindi sila pair, hindi sila conjugate acid-base pair, hindi ka makagawa ng buffer doon kahit anong gawin mo. Okay? So, tinitignan lang natin, you just check kung ilang H lang yung pagitan nila. Tignan mo lang kung pag isa lang yung H yung pagitan nila, conjugate acid-base pair yun. That means you can create a buffer solution out of that. Okay? So, to finish our discussion, eto, medyo out of nowhere. Although, I want you to practice on buffer solutions nga. No? So this is one problem here. Yung una, that's the typical problem, and then yung pangalawa, this is a trick question, no? So gusto ko mag-practice muna tayo dito before we end our session. So let's calculate the pH of a 0.30 molar ammonia, 0.36 molar ammonium chloride buffer system. What is the pH after the addition of 20 ml of 0.05 molar sodium hydroxide to 80 ml of the buffer solution? Yung unang question muna sagutin natin. Kasi ito yung alam natin paano sagutan eh. Calculate the pH of 0.30 molar ammonia, 0.36 molar ammonium chloride buffer system. So the question, is this acid or base? No? Pag nakakita kayo ng ammonia, base agad yon. So that means this buffer system is governed by the Henderson-Hasselbach Equation in base version. So that is POH equals PKB plus log of the conjugate acid divided by the base. So that is this system, this buffer system is governed by this equation. Okay. So ito yung equation na nagko-control dito sa buffer system natin. Kasi base to. Pag ito ay acid, yung pH equals pKa plus log A minus over HA gagamitin natin. So yan. What is the base dito sa dalawang to? E di malamang yung ammonia. Ito yung base. Yung NH4+, ito yung conjugate acid. Okay? So kapag base at conjugate acid yung usapan, yung conjugate acid, 1 hydrogen more than the base. Okay? Counterpart yun ng sa acid. Ang conjugate base ay 1 hydrogen less than the acid. Pag usapang base, ang conjugate acid ay 1 hydrogen more than the base. So yun yung one way to tell. Tignan mo lang yung formula. Kung sino yung mas maraming H, siya yung conjugate acid. That's yun yung base. Ngayon, we already know the concentrations of the conjugate acid and the base. We can now solve for the pOH and the pH of the solution. So before mo solve mo yan, alamin mo muna yung pKb. Walang sinabi, kaya gagamit tayo ng KB table or the KB table. Ayan. So, nabigay ko na yan dito sa PowerPoint. So on this table, we have the KB table of different bases. So for ammonia, that's 1.8 times 10 raised to negative 5. Yan yung KB natin. To get the pKb, that is just the negative log of KB. Okay, so kukunin natin yung pKb from this. Punta na tayo dun sa slide natin. So again, KB is 1.8 times 10 raised to negative 5. Kung gusto nyo kunin yung pKb, that's the negative log of KB. Negative log of 1.8 times 10 raised to negative 5. So we solve for pKb, that's equal to 4.74. So yun na yung pKb. Negative log ng KB, that's equal to 4.74. pOH is 4.74 plus log BH plus the concentration of conjugate acid and the concentration of base. So you can now solve for the pOH, then eventually solve mo yung pH. Okay? Paki-plug in na lang sa calculator. So the pOH is 4.82. In terms of pH, that is equal to 9.18. So that's the pH of this buffer solution. 4.18. May sunog na naman sa Valenzuela. Ang kababat parati may sunog sa amin. So, yan. So, pH is pH is 9.18. When we mix 0.30 molar of ammonia and 0.36 molar ammonium chloride. Ay, ganun lang. Yun na yun. How about the next sentence? So, for the next sentence, sabi dyan, what is the pH after the addition of 20 ml of 0.05 molar sodium hydroxide to 80 ml of the buffer solution? So, ibig sabihin, itong solution natin, siya ay 80 ml initially. Yes, ano ginawa dito? Dinagdagan tayo ng 20 ml ng sodium hydroxide, no, of this concentration. So, yung 80 ml na buffer solution natin, ano na yung total volume niya after? 100 na. So, ano mangyayari sa concentration ng ating chemical species? Madidilute. No? So, ibig sabihin, madidilute itong conjugate acid natin and yung conjugate base. Ay, yung conjugate acid and yung base. Madidilute yung kanilang concentrations. What else? Nagdagdag tayo ng sodium hydroxide. Sodium hydroxide is a base. Ibig sabihin, dadami yung base natin. So, the amount of the base will increase. Yung arrow na yan, pataas na yan. Alam ko, familiar kayo yan. Elsa? No? So, yan. So, tataas yung concentration ng ating base na. So, tataas yung concentration ng ating base. Bakit? Kasi nagdagdag tayo ng sodium hydroxide, no? Okay. So, base, gaganon ka dyan na. Parang Elsa lang na. Tapos may ganun-ganun pa yan na. Tawan-tawa talaga ako doon kagabi. Okay. So, yan. So, tataas yung concentration ng base natin kasi nagdagdag tayo ng sodium hydroxide, no? Ano mangyayari sa ating conjugate acid? Pag tumaas yung base, mababawasan yung ating conjugate acid. Okay? So, again, pag nagdagdag ka ng base, tataas yung concentration ng base. Then kapag ang counterpart nun, bababa yung concentration ng inyong conjugate acid. So magkasaliwaan sila, no? Pag nagdagdag ng base, tataas yung base, bababa yung conjugate acid. Pero pag nagdagdag ka ng acid diyan, yung conjugate acid mo tataas, yung base mo bababa yung kanyang concentration. Okay? Ganito yung nangyayari sa titration. Nagdadagdag tayo ng acid o kaya ng base. So, sa result, tumataas yung ratio. Tumataas baba yung ratio nilang dalawa. Okay? So, itong arrow na to, pataas. Alam nyo na kung paano basahin yan. Okay? Panoorin nyo na lang yun nasa TikTok. Okay. So, ayan. So, baguhin natin tong problem na to, no? Kasi may binago sa ating system. Ang sabi dito, yung 80 ml nating buffer, sabi dito, dinagdagan siya ng 20 ml na sodium hydroxide. So, ibig sabihin, na-dilute na yung original concentration natin. O, ipakita natin na diluted sila. So, kopyahin lang natin to. So, kopyahin lang natin yan. Using dilution formula. Kabisado nyo pa? Dapat kabisado pa rin. M1 V1 equals M2 V2. O yung final, molarity 2 equals initial molarity, initial volume V2. O in our case, the initial molarity, o yun sa numerator muna, that's 0.36. Initial volume is 80 ml. And the final volume after the addition of 20 ml niyan ay 100 ml. Nagdagdag kasi tayo ng 20 ml, di 100 ml na yung final volume. So what will be the new molarity? What will be the diluted molarity? Yung 0.36 natin, magiging 0.288 na siya. Nag-dilute tayo eh. How about yung 0.30? Palitan ko lang to. Sa denominator, how about the 0.30? So, palitan ko lang to ng 0.30. So that's 0.30 times 80 divided by 100. So yung 0.30 dati, ngayon ay 0.24 na. Kasi na-dilute. Bakit natin pinalitan to? Kasi na-dilute yung ating system. Nagdagdag tayo ng additional solution eh. So tumaas yung volume niya. So, dapat ma-dilute tong concentrations nila. Okay. Na-dilute na sila. Pinakita ko na yun doon. What else? Ano pa yung nangyari? The other thing that happened is that we added a base. Okay? So, eto, sabi dito, yung base, tataas siya. So, ibig sabihin, magpa-plus pa tayo sa denominator. Mag-a-add tayo dito sa baba. And sa numerator, magbabawas tayo. Bakit? No? Kasi hindi lang dilution yung nangyari sa atin. We also added moles of the base. Nagdagdag tayo ng base eh. So, nagdagdag kasi tayo na ito. So, ibig sabihin, may plus sa denominator kasi andun yung base and may minus sa numerator. Kasi sabi natin, when you add base, bababa yung conjugate acid. By how much? O, alamin natin gano'ng karaming, ano yung molarity ng base yung dinagdag sa atin. So, from this info here, let me highlight. Okay. So, you are given 20 ml of 0.05 molar sodium hydroxide. So, kunin mo muna yung moles natin doon. Kunin mo muna yung moles ng base na dinagdag, no? So, that will be 20 ml times 0.05 molar. That is 1 millimole of base added. Okay? Pero ang gusto natin ay concentration kasi yun yung equation natin, concentration siya. So you divide the millimoles of base added to the final volume. No? Conc of the base added. So you just divide the millimoles of the base added by the final volume, which is 100 ml. So 1 millimole divided by 100 ml is 0.01 molar. So that means yung base mo may madadagdagan by 0.01 molar. Yung inyong conjugate acid mababawasan by 0.01 molar, no? To the same extent. So the resulting pOH is now equal to tintype ko lang, dami nakalagay eh. So the resulting pH is now 4.79. pOH yun, 4.79. And yung ating pH can be calculated as 14 minus 4.79. That's 9.21. That's the final answer. Again, paano tayo nag-arrive dito sa sagot na to? Paano tayo nag-arrive dito sa answer natin na to? Sabi natin, ganito. Nung nagdagdag tayo ng base, tumaas yung volume ng solution. From 80 ml, naging 100 na. Kasi 20 ml yung dinagdag mo. Kaya ginawa natin, unang ginawa, dinilute natin yung mga concentration ng conjugate acid and the base. Ito na yung kanilang diluted concentrations. Tapos, sinasabi natin, nagdagdag tayo ng base, tataas yung base natin. Parang si Elsa. Mas bababa naman si conjugate acid. Okay? So, pag sinabi kong tataas yung base, plus concentration ng base added. Yon. Pag sinabi kong bababa yung conjugate acid, minus the concentration of base added. Yon. So, ano yung concentration of the base added? Paano mo malalaman yon? First, you determine the moles of the base added, multiply the volume by the molarity. So, we get 1 millimole. Then finally, to get the concentration, you divide the millimole by the total volume of the solution, which is 100 ml. That's 0.01 molar. Etong adjustment natin na 0.01 molar, i-plug in mo yun dito. Okay? And then by solving, we get a pH equal to 9.21. Does our answer make sense? It makes sense. Bakit? You added a base. So most likely, tataas onte yung pH. Pero eto pansinin nyo ha. Ang dami nating dinagdag na base. Pero ano nangyari? Onti lang yung changes sa pH. No? Onti lang yung change niya. Sir, di ba 3.61? Repindot natin. So 4.74 plus log. On numerator, 288 minus 0.01. Sa baba, 0.24 plus 0.01. 4.79 po. Retry na kasi lumabas sa akin 4.79. Recheck nyo na lang. Baka may may maling symbol. Baka may nabaliktad lang na symbol. Double check na lang. But the answer is for POH, that's 4.79. Ayun. Ayan. Okay. So, ganun lang gagawin nyo ha. Kapag kayo ay nagdagdag ng base sa base solution, tataas yung base, bababa yung conjugate acid. Pag kayo nagdagdag ng base sa acid solution, mababawasan yung acid, madadagdagan yung conjugate base. So isipin nyo na lang, pag nagdagdag ako ng base, tataas yung base ko, whether that's a base or a conjugate base. Pag nagdagdag ako ng acid, mababawasan, pag nagdagdag ako ng acid, madadagdagan naman yung acid ko or the conjugate acid. So either of those two lang yung mangyayari. So again, pag tumaas yung base, tataas din yung conjugate base. Bababa yung conjugate acid o kaya bababa yung acid. Ito, in general na to ha. Okay. Pag nagdagdag ka naman ng acid, tataas yung conjugate acid concentration, bababa yung concentration ng base, bababa yung concentration ng conjugate base. So, itong dalawa yung general, lang dyan, general idea. Pag nagdagdag ka ng acid, yung mga acid dadami, mababawasan yung base. Pag nagdagdag ka ng base, madadagdagan yung bases, mababawasan yung acids. Okay? So, yun yung overall idea. In our case, nagdagdag tayo ng base. So, lahat ng base tataas, yung mga acid, even the conjugate acid, bababa sila. Okay? So, ganun lang. So, that's how we approach this problem. I will give some more items like this, no, sa ating worksheet, no, para mag-practice para ma-practice kayo, no. Okay, so magbibigay pa ako ng some more items dito, pero not that much, no. Kasi again, magsasawa kayo sa ganitong type ng questions pagdating natin sa titration. Ganito kasi yung concept ng titration. Magdadagdag-dagdag ka ng base or acid, tapos mag-a-adjust ka dito. Magbabago-bago ka ng amounts dyan. So magsasawa kayo sa Henderson-Hasselbach Equation by the time we reach titration. Okay, so for now, let's call this a day na lang. Okay. So, okay na muna yan sa ngayon. Okay. So, again, ito nga, isang application. So there are many buffer systems in our body, one of which is the carbonate buffer. Okay. So suppose this is our this is the blood cell natin. Okay, especially yung ating red blood cell. So mapansin natin sa ating cell mismo, meron tayong carbonate buffer. We have a carbonate bicarbonate buffer. No. Okay, so yan. Teka lang, may question si April. Balik ulit tayo dito. Um, so sabi ni April, wait lang. Sir, paano po kung di given yung concentration ng niad? Ibibigay talaga yan. Hindi pwedeng, hindi bigay kasi hindi mo talaga siya masasolve pag ganun. Sasabihin kung ano yung concentration ng inad mo talaga. Kasi kapag wala to, hindi na natin siya masasagutan talaga din. So, given siya always. Okay? So, yan. So, more of that will be discussed in depth pagdating natin sa titration. Okay? So, punta na tayo sa ating last part for this session. So, sabi ko nga sa inyo, our body system has lots of buffers. No? Example doon is yun sa ating bloods, no? Sa ating mga dugo-dugo, no? Okay. Sa ating mga RBCs, no? Okay, so ito yung itsura ng ating blood, no? Yan. And maintain yung shape na yan. Itong blood natin ay isang malaking protein lang yan. No? Maintain yung shape na yan dahil sa buffer system natin. So we have a carbonate bicarbonate system. Okay? So, yun. So, dahil dyan na maintain yung pH ng blood around 7.4. If you happen to change the pH of your blood, no, kunwari baguhin mo yan from 7.4, gawin mong 6, doon ka pwede magkaroon ng sakit, no? Kasi what will happen is that at different pH, your protein will behave differently. Pwedeng masira yung protein mo. The same reason as yung sa itlog, yung egg white. 'Di ba? Lagyan mo yan ng suka, masisira agad yun, no? Ganon din sa ating blood. Protein din kasi yung blood, no? So, when you change the pH, too much, yung ating shape ng blood, masisira. So, deads tayo. Magkakaroon tayo ng sakit, no? So, that's why important yung buffer system. They try to keep the pH of the blood, no, to a tolerable level so that the shape of the protein will be intact, no? Magiging fix yung kanyang shape. Because at other pH, the proteins, pwede silang ma-denature, pwede silang masira. Okay, and as a result, your protein will no longer work. And that's a bad case for a red blood cell because RBCs transport oxygen needed for our cellular respiration. So without oxygen, hindi magpo-produce ng energy ang ating cells sa body. Therefore, we will die. No? So, yan. So, yan. Yan yung isang importance ng buffer system. No? Marami pa, actually. Okay? So, you will discover more of those in your biochemistry next year, next academic year. Okay? Mabilis, no? Second year agad kayo after this year. Okay, so anyway, for the next session, we will talk about the solubility equilibria. So I hope you are able to discuss sa sa lecture yung electrolyte effects, yung mga Diprotic equation. So hopefully na-discuss na sa inyo yan. Although hindi natin yung magagamit dito sa solubility dito, maganda na rin na may idea na kayo kung tungkol saan itong solubility natin na to. Okay? So again, your quiz will open starting Monday. Dalawang parts yan. So for the first part, ito yon, quiz 4 part 1. So multiple choice question na lang. Okay? And then adjusted yung time. Then this will open by Monday until Wednesday. Then for the last part, this will open from Thursday until Saturday. Okay? So this will be quiz 4 part 2. Anong date po midterm? So the midterm will start by March 15 until March 20. So ang March 15 to March 20 yun ay 6 days, no? Pero I think isasagad nila yun ng 7 days. Just like last semester. Diba last semester sinagad ng 1 linggo? Okay. So ganun. So yung midterm nyo starting March 15 to the weekends, no? So, yun. So, by next week, ang ating last discussion ay about dito na lang. So, sa Monday, didiscuss natin to very shortly. Madali lang naman kasi yan. Basta alam nyo gumamit ng iStable, madali na lang to. Okay? So, yan. So, this will be a very short discussion on Monday. So, you have plenty of time pa to work on these items. By the weekend, mag-upload ako ng worksheet for chapter 4. No? So, medyo na-busy lang ako lately because of school then. No? Kaya, yun. So, this is, I will try to upload the worksheet agad-agad. No? Para makasagot kayo. Okay, so yan. So, bakit pwede ko naman to kasi overlap sa schedule sa midterm. However, ayoko gawin na lang yan. Para naman makapag-focus din kayo sa other subjects. No? Kaya, next week na lang, doon na lang natin sagarin yung assessments for this subject. So, sensya na, sabay-sabay, no? Ganun talaga, no? So, wala tayong magagawa. May suspension nakaraan, no? Kaya, yan. Okay. So anyway, again, on Monday, we will discuss the solubility equilibrium and the common ion effect. Yung diverse ion effect, sa lecture yun i-discuss. Hopefully, tapos nyo na. Okay, and yan. Kailan ulit tayo magkikita-kita? No? So most likely, tayo ay magkikita-kita ulit by, tingin tayo sa calendar. So ito, Monday, this will be our last class for the midterm. Wala na tayong class for Friday. Tuesday pala kayo, sorry. So ito yung last class natin. Then on Friday, wala na tayong gagawin. Go-quiz na lang kayo. This will be the midterm exam. And then this will be the consultation week. So, wala masyadong gagawin dyan. Holy Week, no? So sana Holy Week ay ewan ko ano mangyayari sa Holy Week. Nasa bahay tayo. Second Holy Week natin sa bahay. Ito na pala yung anniversary ng ating lockdown. Okay. So sad. And then, dito, most likely, April na tayo makapag-start with the chapter 5, no? Sa titration. Then, imagine nyo, after ilang weeks, matatapos na uli yung SEM. Diba? Second year na kayo. Bilis, no? Okay, so, ganun lang. So, yun, paki-keep in mind na lang yung schedule natin. So, Tuesday, klase. Tapos wala na dito. Midterm to. Most likely, consultation week to. So, walang gagawin dyan. Semana Santa. Holy Week yan. Then, we will have our chapter 5 on the first week of April. Second week. Considered pa rin pala to as first week. Okay? So, yan. I'll see you again next Tuesday na. So, stay safe always. As always, no? And a copy of the PowerPoint will be uploaded on YouTube. And yung worksheet, mag-update na lang ako sa chat box natin pag meron na. So, ingat, stay safe, and good luck. And dumating na yung vaccines from AstraZeneca, magpa-register na kayo. Okay, so yan. Okay, ingat, bye-bye.